In this lecture, let us create a new module in Terraform and then put it to use to deploy multiple environments of the same infrastructure. Let us assume that an organization called Flex IT Consulting has a blueprint of a prototype payroll software that needs to be deployed in several countries. Each country will have its own instance of the software deployed on AWS Cloud using the same architecture. It has a single EC2 instance using a custom AMI that will host the application server. A DynamoDB NoSQL database that will be used to store the employee and payroll data. And then we have an S3 bucket which will be used to store documents such as pay stubs and tax forms. Users access the application which is hosted on this EC2 instance. This is an architecture in its most simplified form that uses the default VPC and does not consider things like VPC endpoints or IAM roles for the services. The architecture diagram at a very high level looks like this. So, the idea here is to create a reusable Terraform module and use it to deploy the same stack of resources in different countries. And based on this high-level architecture, we can create our configuration in a directory. Since we plan to create a module, we create it under the directory called modules. For instance, let's use of the path /root terraform projects/modules. This is where we plan to store all our reusable modules. Inside this, we have the resource block for all the required services such as the EC2 instance, S3 bucket, and DynamoDB. To ensure that we have consistent environments and to use a specific instance type for all the environments created by the module, the value of instance type has been hard-coded into the configuration file like this. We'll soon see why this is done. The AMI, however, is set to the variable called AMI and is user configurable based on the region where we want to deploy the application. Same goes for the tag called name. Here, we are making use of an interpolation expression to use the value of name which depends on the region where we want to deploy this application. Also note that an explicit dependency is defined in the EC2 resource block to ensure that it is only created after the DynamoDB and the S3 buckets are provisioned. And the same goes for the S3 bucket name. To ensure that we have a globally unique name for the bucket, we are adding the region as a prefix for the bucket name. Finally, the DynamoDB name and the primary key for the table have also been assigned fixed values. Please note that to improve the readability, the configuration files that you see here have been truncated. And our variables for this configuration would look like this. The variables called app_region and AMI just have the variable type defined in the block. The variable called bucket, however, has a default value assigned to it as well. These variables have been used in the configuration files that we just saw. Now, let's deploy an instance of this application stack, first in the US East 1 region. To do this, let us create another directory called US Payroll App, and inside this directory, we create a main.tf file with the contents like this. Here, we'll make use of the module block and specify the path to the payroll app module that we created earlier. To make sure that we deploy to the US East 1 region and use the custom AMI ID in that region, we can specify the app_region and the AMI in our root module like this. And that's it. Since this is our working configuration directory, the path /root/terraform project/US payroll app is now the root module, and the modules directory, which is modules/payroll app, which is used as the source, is the child module. You would have noticed that the only configurable value in this main.tf file is the app region and the AMI ID. We can also optionally provide a specific value for the bucket argument, but if it is not, it will take the default value that was set at the module level, which in this case is flexit-payroll-alpha-22001C. We do not want the instance type, the DynamoDB name, and the primary key to change, and this is why we have hard-coded the values in the module configuration. With just this module block, our configuration file is now complete and ready to be applied. If we run Terraform init now, we'll see that Terraform downloads the module from source along with the AWS plugin which is used by that module. A plan followed by apply will show that the DynamoDB table, the S3 bucket, and the AWS EC2 instance are created. Observe that the DynamoDB table name, the primary key, and the instance type for the EC2 instance take values that we have defined at the child module. The bucket name and the AMI ID, on the other hand, makes use of the values that we have defined in the root module. To deploy the same stack in the UK region, let's create another directory called UK Payroll App. We then follow the same process of creating a main.tf file and then make use of the same module block. Inside this module block, we use the value of EU West2 for the app region. We have also changed the AMI ID to select the one that's available in this region. Running the Terraform workflow now will create the exact same stack but in the London region. Notice that the name of the S3 bucket created now has the prefix of EU West2. Since we are making use of a module, the DynamoDB table resource that has been created is now identified by the addressing syntax that goes like this. First comes the module address, which is the keyword module followed by the module name, which is separated by a dot. Next comes the resource address, which is the resource type followed by the resource name, also separated by a dot. So in this example, the DynamoDB table resource in the root module can be addressed as module.uspayroll.awsdynamodbtable.payroll.db. We have now successfully created a Terraform module and used it to deploy multiple instances of our application in different regions. Modules are comparable to libraries or packages that are used in most programming languages. This brings in a lot of benefits such as simpler configuration instead of having configuration files that contain hundreds and thousands of lines of code. Our root module now is very short, easy to understand and manage. Using a pre-configured module that has been tested and validated also decreases the risk of human errors resulting in inconsistent environments. As we just saw, the same module can be used to deploy the infrastructure in different regions, thereby improving the reusability of our code. And finally, by making sure that certain aspects of our configuration are fixed, such as the DynamoDB table name, the primary key, and the instance type, which are not user configurable from the root module, we can make sure that the provisioning process maintains a standard configuration. That's it for this lecture. In the next one, we'll see how to make use of modules from the public Terraform registry.